In this video, I am going to demonstrate how to use desirability function approach to maximize the or optimize the process. Now in this case, I have two variables x1 and x2. x1 is the reaction time and x2 is the reaction temperature, and I want to improve my yield, which is given by this response y1. The data is collected through central composite design experiment, and for that I need, and to optimize it, first I need a model, and under analyze fit model I'm going to first select the response variable, and since I know that only x1 x2 and if you click on here polynomial 2 degrees, so it will add the square term. So I know from my experience that x1 x2 x1 square and x2 square, only these four terms are significant, so I'm just going to add those terms in the model and click on then effect leverage and then click on run. Now all these variables in the model are significant. To optimize, under this red triangle, click on factor profiling and profilers. Now once you get this type of output, click on red triangle, go under optimization and desirability and choose desirability function. Now under this red triangle, again click on again choose optimization and desirability, then go to set desirability. Now first thing you need to specify, okay, what is the goal? My goal is to maximize the yield, so I'm going to select here maximize. Now it is asking, okay, what is the highest value that you will allow? So I will say, okay, if the highest value is like 85, so if you achieve 85, I will be very satisfied. So any value, if it is the yield is 85, if the optimum value is selected in such a way that I'm getting an yield of 85, I will be very satisfied, and beyond 85 also it goes, I will be highly satisfied. I will be satisfied, in short. Then lowest value, what I want is okay, it should achieve a lowest value at least 80. So beyond 80 only I want the yield to be. If yield is below 80, that is not acceptable to me. If yield is above 80, only that is acceptable to me. So I will here write desirability as 0. And in between 82.5, if I take only the linear function, it is 82.5, and desirability will be around 0.5. Now hit OK, and now go to this right triangle, optimization and desirability, click on maximize desirability. Now it will run an optimizer, and based on these values of x1 and x2, we have achieved a yield of we have achieved the yield of 80.18. Now 80.18 is very close to 80, our lowest limit, so that is why the desirability is low, 0.04. So this number is being converted into a scale of 0 to 1 using the desirability. It is keeping in mind what is the highest value, what is the lowest value that you gave, but yield is 80.18, and it is actually only the desirability is 0.04 as per your aspirations. Now if it's change, let's say highest value to 82, okay, and desirability is 1, the middle value to 80 and lowest value to 78. So that means if I get an yield of 82 or beyond, I will be highly satisfied. So that is why desirability is 1. If I get an yield of 80, the desirability is 0.5, and if I get an yield of 78 or below, I won't be satisfied, so that is why it is 0. So click OK, and just see this number 80.18, and again I am going to maximize the desirability. So you see the number has not changed, because yield that maximum I can achieve is 80.18, but you see the desirability has been changed, 0.54. So why desirability is changing? Because we are playing with the highest permissible value and the lowest permissible value, and therefore desirability number may change from person to person as per their decision making criteria. We have other type of output variables also, like in the yield I wanted to maximize, so that is the yield. I can also minimize some objective function. In that case, what I need to do is, suppose if I want to minimize an objective function, so for that go to set desirability and choose minimization here. Now highest is that what is the uppermost value that you may permit. So let's say 82, here the desirability will be 0. So I want a value of that particular, let's say in this case I want to minimize the yield hypothetically. So here I will write 82 as the highest value which is permissible, and I want a solution which is below 82. So that is why the desirability is 0. So optimizer will work hard for getting a value which is below 82. And let's say again the lowest value is 78. So the lowest value is 78. That means in this case, if it achieves 78 or below that, I will be very satisfied with the results. And if it is 80, I will be like 50% satisfied. So the same thing what we did for the maximization can be done for minimization, only the direction of desirability will change. The third type of response variable that we see sometimes is match the target. Okay, it looks something like this if you see this linear part. So if it is at particular value, then I will be very satisfied. But if it is deviating from that particular value, which is my target here, my desirability will decrease or my satisfaction will decrease. So for example, here I want yield exactly to be 80. Okay, let's say if I want yield exactly to be 80 and maximum deviation on either side I can tolerate is plus minus 2. So if it moves from 80 to 82, then I won't be satisfied, so it is 0. If it is 82 or beyond, I won't be satisfied. If it is 78 or below that, I won't be satisfied. So I will be satisfied when it is exactly hitting the 80. If I click OK and then go to optimization desirability and maximum desirability, you will see that exactly I am able to actually hit a target of 80 if these are the process setting conditions, and I am getting perfect desirability of 1. So we have three type of objective functions. One is match target. So when you want the value to hit some particular number and other numbers, if they deviate from this particular number, your desirability decreases. Then we have maximization and we have then minimization. So this is how you use the desirability function for maximizing or optimizing a process. Thank you.